Going to all. Now I discuss the topic of influence lines for determinate beams. So overview of influence lines for statically determinate structures, introduction of influence lines, and influence lines for beams, palliative methods, influence lines for floor girders, influence lines for trusses, live loads for bridges, maximum influence lines at a point due to series of concentrated loads, absolute maximum shear and moment. So first of all, the introduction of influence lines. Influence lines describe the variation of an analysis of variables. So reactions, shear force, bending moment, twisting moment, deflection, etc. at a point at C. So shown in figure, simply supported beam A and B supported and C twisting moment and shear force reactions, the deflection. So why we do the difference lines? For instance, of when loads passes over a structure, say a bridge, one needs to know the when the maximum values of shear reaction bending moment will occur at a point, so that the section may be designed. So notations are normal forces. Positive forces has a positive displacement in positive directions. Shear force. Positive shear force has a clockwise rotation and negative shear force has anti-clockwise rotations. Bending moments. Positive bending moments cause cup holding water deformed shape. So next one is influence lines for beams. Procedure. Allow a unit load either 1B, 1 Newton, 1 kilo or 1 ton to move over a beam from left to right. The find the values of the shear force or bending moment at the point under the consideration of the unit loads moves over the beam from left to right. So plot the values of shear force and bending moment over the length of the beams commuted for the point under considerations. So next one is moving concentrated load. So variation of reaction RA and RB as functions of load positions. So first one is the A, the forward direction and backward directions. So the distance of X, the center point is C. So the distance of a span of 10 feet. So A to C point is 3 feet. So reactions moment about A equal to 0. So RP into 10 minus unit load 1 it is at the distance of the X. So 1 into X equal to 0. So RB equal to X by 10. RA equal to 1 minus RB. So summation B equal to 0. Vertical reactions summation B equal to 0. RA plus RB equal to 1. So RA equal to 1 minus RB. So already find out the reaction of RB X divided by 10. So substitute the values of RB, RA equal to 1 minus X divided by 10. So this is RA reaction and RB reactions. So RA equal to 1 minus X divided by 10 and RB equal to X by 10 at the distance of the X. Next one is RA equal to 1 minus X divided by 10, RB equal to X by 10. At the distance of X, the section of the C over the loads of a point load, and then RA occurs only at A, RB occurs only at B. So influence lines for RA. So RA find out the this distance is 1 kilonewton. So X distance is cut by the section of into the 1 minus X divided by 10. So distance X, remaining distance 10 minus X. So overall length 10 feet. So this is the influence lines for RB. X divided by 10. X divided by 10. Distance of AX. The shear force is X divided by 10. Next one is 10 minus X. This is unit load is 1. So variation of shear force at the C as a function of load positions. 0 less than X less than 3 feet unit load to the left of C. So unit load is 1 kilonewton. The distance of X. So overall the position of the C 3 feet. So RE equal to 1 minus x divided by 10, RB equal to x by 10, overall span 10 feet. Shear force at the C is negative force, BC equal to minus x by 10. So 3 less than x less than 10 feet unit load to the right of C. So right portions uh, B to move the directions of unit load to right of the C. So reactions of RE equal to 1 minus x divided by 10. So midpoint of C, the cut by the sections of positive shear force and negative shear force. So positive shear force L minus x divided by L. So L values is 10 feet. So substitute the values of L minus x divided by 10. So find out the 0.7. So L is 10 feet, X is 3 feet. So 10 minus 7, 10 minus 3 equal to 7. 7 divided by 10 equal to 0.7. So positive shear force is the ordinate of the values of 0.7. And then negative shear force is L minus X. So L is 10 divided by X by L. So X is 3 divided by 10. So 0.3. So the negative shear force is ordinate is 0.3. So the total values of 0.7 plus 0.3 equal to 1. Uh, this is influence lines for shear force at the C. Next one is the variation of bending moment at the C as a function of load position. 0 less than x less than 3 feet. Unit load to the left of C. So reactions A and B at the section of C. Unit load apply for the left of the support C. This is a point load and the distance of x. A to C distance is 3 feet and the remaining distance is 7 feet. Total span is 10 feet. So R equal to L minus x divided by 10, 1 minus x divided by 10, and RB equal to x by 10. So the reaction of the moment is for negative and positive, and then clockwise direction is x by 10 into L. So the load is x by 10, and this direction is x by 10 divided by 7. This direction is x by 10. Bending moment is positive at the C. Next one is 3 less than x less than 10 feet. Unit load to the right of C. A and B supports. Midpoint is C. The unit load is right of the C. Apply for the unit load. Right of the C or the point of the apply for the apply for the loads, and then the moment RA equal to 1 minus x divided by 10. RB equal to x by 10. The feet of these 10 feet total span. The reactions of the support at the bending moment, influence lines for bending moment at C. The moment C is positive, so this ordinate positive ordinates L x into L minus x divided by L. So x 3 feet and L minus x divided by x divided by L. So 2.1 kilonewton kilonewton meter. So the used for the feet. So 2.1 kilonewton feet. So this is the um, influence lines for determinate beams. So first one is find out the ordinates. Find out the ordinates and then positive shear force and negative shear force bending moment is fine to the influence lines for the graphical representation of the diagram. So next one is Qualitative influence lines, Muller principles. This is only procedure for the to determine the influence lines for parameter determinate or indeterminate structures. By using the basic understanding the influence lines, magnitude of the influence lines also can be computed. In order to draw the shape of the influence lines properly, the capacity of the beams to resist the parameter investigator, reaction, bending moment, shear force, etc. at the point must be removed. The capacity of the beam to resist the parameter at the point must be removed. Then allow the beam to deflect under the parameters. So positive direction of the force are same as before. So this is the Muller principle methods that follow to the influence lines for reaction at the A, and influence lines for shear force at the C, influence lines for bending moment at the C. So this is the influence lines for shear at E. This is floor girders. Floor systems are constructed as shown in figures. So trusses form to the elevations and the plan. So draw the influence lines for shear in panel CD of the girder and V the moment at E. The force equilibrium methods is followed to the shear force. And then place load over the region PC 10 feet less than X 20 feet. So this is used for the continuity problems of positive shear force and negative shear force. Find out the moment. So the maximum shear force and bending moment under the series of concentrated loads. So point load P1, P2, P3, P4. The distance of A1, A2, A3. So form the simply supported beam. At the 4 point loads P1, P2, P3, P4. A1, A2, A3 distance at the section, cut the section of the X directions, taking moment about A or E into L equal to P or L by 2 minus X bar minus X or equal to P r divided by L by 2 minus X bar plus X. So this is the reaction of E. And then taking moment about E, R into L equal to P r into L by 2 plus X bar minus X. So find out the RA equal to PR divided by L by 2 plus X bar minus X. So moment about D, RA into L by 2 plus X, P1 A1 plus A2 minus P2 into A2. The difference of a moment about D equal to 0. So X equal to X bar divided by 2. The central line must divide the distance between the resultant of all the loads in the moving series of loads and the load considered under which the maximum bending moment occurs. So this is the final result of the absolute maximum bending moment and then concentrated loads of the moving loads. Thank you.